Hello and welcome everybody. I'm actually quite excited to be here on the big stage, so that's pretty cool. So my name is Robert. I think I've been introduced. You can figure out easily what I do. So I work at Raiffeisen Bank International as a DevOps community lead and also as an engineering coach. So let's jump right in. Yeah, so if you happen to be Austrian, and if you happen to be of a certain age, then probably you know this guy. His name is Fred Sinowatz, and he was the Austrian chancellor in the early 80s. And he actually became quite famous because of this quote. Yeah? He said it during a speech in the parliament in 1983. I was a kid at that time, but I still can remember that media and political opponents used to make fun of him. Yeah? Because, and I think the situation hasn't changed that much. It's still expected from politicians and leaders in general that they have strong opinions and take fast decisions. When I grew up and became a bit more interested in politics, actually I was remembering this, and I just couldn't figure out why at the time he said this kind of thing. Yeah? So I did some research. And this is what I came up with. Yeah? This is what he actually said. And if you read it, it's actually really, really true. Yeah? So it was just the quote is just really like the shortened form. But what he said is actually the truth. And I think at that time, this was the first time where I consciously figured out that most of the things that we have to deal with in our environments are of a complex nature. And what I also figured out was that many people have a hard time accepting this. And it's also hard to explain this to people. So we've heard a lot about these kind of things already today, so I don't want to tell you anything about Kinefin, whatever. Yeah, so you've seen this sign. I don't have it in my presentation. Actually, Dave Snowden was here a couple of months ago at another conference here in Vienna and did a very interesting talk about this. But it is clear that we need to have some strategies how to cope with this kind of complexity. And one of this, and of course that's the only one that really helps us in the long term, is to have this kind of feedback cycles of sensing and learning. But, I mean, there is another thing that we can do. And but maybe first, I just want to show you what my current approach to this kind of complexity is, because I've been working in the software industry now for many years, and this hasn't changed my attitude towards this. Yeah? Things are complex. We have to deal with it. Now, one strategy to deal with this is the application of patterns. Yeah? Let me explain a bit what I mean with this. First, some kind of definition. I read it so I don't make any mistakes here. So, patterns are generally repeatable solutions to a commonly occurring problem. This is something that's actually quite useful. We as human beings, and I think that's pretty clear, also after the other talks, have a hard time to live with ambiguity and uncertainty. It's just like really hard for us to deal with this. So what we try to do instinctively, we try to make sense of stuff. Yeah? And we do this by applying some familiar patterns that we see to make sense of this complexity. Yeah? So it's like a pretty normal strategy. It is also a good strategy if we want to start in figuring out how to solve problems in the complex problem space. But it is clear we need to be really, really careful with this. Yeah? We as people tend to simplify and also have a lot of biases. So we need to be really conscious in applying this kind of approach to solving complex problems. But still, it is a powerful tool if we apply it in the right way. Now, typically, we just need to apply a set of patterns, a multitude, because one pattern doesn't help us to solve the problem. So there is this concept of a pattern language, and also I have a short definition here. It's pretty straightforward. So pattern languages are a collection of related patterns that work together to solve a problem in a particular context. Context is always extremely important if we talk about patterns. Yeah? This is not like a framework or something that we could use like a cookie cutter. Right? It always requires the consideration of the context. The idea of a pattern language was actually introduced by Christopher Alexander with this book in 1977. It's a very, very interesting book. I mean, the title says it all, it's pattern language. Christopher Alexander was an architect, and this book describes patterns that help to solve common problems in the construction of buildings, towns, and cities. So just to show you an example how this looks like, this book is really beautiful. I can only recommend to read it. It's like there is so much humanity in it. It's a great read, although it's not easy. Just as an example, yeah? And this fits very well also to what you showed, Eduardo. One pattern, and this is pattern 103, says small parking lots. Yeah? So this is something that we should apply when we think about how we build our cities. And the comment is, vast parking lots wreck the land for people. I just hope that all of our city planners and politicians read this, but living in Vienna for quite some time, I'm not so sure. There is way too much space for cars for my taste. So this concept of a pattern language that was derived from architectural patterns actually created a lot of interest also in the software architecture community. I found this really interesting. And we have pattern languages for software developers. Who of you knows this book? There are a couple of people. So this is the famous Gang of Four book about design patterns. So if you ever heard about singletons, factory patterns, or this is stuff that is described in this book. So you should read this if you are a developer. When I started as a developer in 1999, I think, yeah, after 2 weeks, my boss gave me this book, and I have to admit I was pretty overwhelmed and intimidated. But it's still a super nice read. So I think by now it is kind of clear that we can apply this approach of a pattern language to multiple problem spaces. And what I want to talk about is the problem space of organizational design. But organizations can have, of course, a multitude of different purposes. So we need to narrow down the scope a bit. And I'm mainly talking about IT organizations. Yeah? IT organizations that actually provide value to customers. This is the kind of organizations that I'm talking about. We already know that, and I think this was also explained already quite clearly by by Eduardo and also the Jespens, that one of the main characteristics of an IT organization must be that we are able to deliver changes frequently. We need to collect feedback fast and learn from it. Yeah? That's the only way how we can accommodate these constant changes in requirements in the markets in our environments. The good thing is, yeah, there is a good and a lot of empirical evidence how we can do this in the context of software development. I think most of you will have heard about DORA metrics and the Accelerate book. There's a lot of empiric evidence that if we as a software as an organization that delivers software are able to deliver these kind of changes fast and collect feedback fast, that there is a strong correlation also with business outcomes. Yeah? So we need to take this into consideration, otherwise we won't be successful from a business perspective. So first thing that our organization needs to achieve is this kind of fast flow of changes, fast flow of value to our customers. This is important, yeah? And as most of the companies nowadays, independent of in which area they are operating, are driven by software, so we are talking about a broad range of different potential companies. The second thing that we need to consider if we talk about an organization is whatever we come up with, it must be good for us as human beings. You may call me naive or idealistic, but I still think that it is kind of our duty to make sure that the environment we are working in is rewarding and allows us to grow as human persons. Yeah? I think this is super important. Many of you may have heard about this concept of intrinsic motivation, the motivation that comes really from within. And this is the kind of motivation that also keeps us attached to our jobs and at the end allows us to be creative and innovative. Yeah? So even if we look at this kind of thing purely from a pragmatic or business perspective, creating an environment where people feel safe and where they can grow is really kind of out of the question. Any organization that we need to come up with also needs to fulfill this kind of requirement. But then there's a third thing, and That's what I call the coherence of software, architecture, and organization. We've already heard about this friendly guy. Yeah? This is Mel Conway, and he introduced or proposed Conway's law in 1967. This is how it was written. It sounds like a bit technocratic, but at the end, what it means is that the way how we design our organization will have significant impact on the software systems that are generated by this organization. I mean, it's not only true for software systems, it's more generic, but I'm talking about organizations that do software. Famous example of this is that if you have 4 teams and you ask them to develop a compiler, then probably you will get a 4-pass compiler. So now we know that we have some properties in our software architecture that are desired, and like the most important thing is like cohesion and coupling. Yeah? So things that belong together should be close together. Things that are not so closely related should be clearly separated. If you change one thing, it should not impact the other thing. Loose coupling. Yeah? So 2 most important principles. Now, what if we could come up with an organization that would help us so that these kind of desired properties emerge? Yeah? And actually, this is looking at this organizational problem from the other way around. So we design our organization in a way that we have the properties of the architecture that we desire. They should emerge from the organization. And this is actually something that's called the reverse Conway maneuver. So we consciously decide on a specific organization so the properties that we want to have will emerge. So we also heard that, Robert said it in the early beginning, this has a lot of interesting implications because it means that we can't leave organizational design to some kind of HR department. Yeah? We need to bring in our knowledge and experience of system architecture. Otherwise, we will have unintended results and it will be really bad for our solutions. So what it is finally and eventually, organization design is an engineering problem. So, yeah, another problem that we have to solve as engineers. Good, so having said all of this, I think we now have a good idea about how our organization should look like. Yeah, as a good IT organization, capable and effective, good for us as people. Now, let's talk about the pattern language that enables us to come up with an idea about this organization, that allows us to make sense about the complexity of the design. And this is team topologies. It's an example. Yeah? I see it as a pattern language for organizational design. The book was released in 2019, authors Matthew Skelton and Manuel Pais. And the name is something, I think, where we need to unpack a bit of stuff. Yeah, I have to admit, topologies sounds fancy, mathematical. I'm a physicist by training, so I was immediately, this was immediately attractive to me, a bit nerdy, so pretty cool. So topologies, and that's the standard definition from a dictionary, just means that it is the way in which the parts of a system, the parts that are an integral part of the system, are interrelated or arranged. So we're talking about parts of a system plus their interaction and their arrangement. Yeah? Plus, there is a subtitle of the book, and that says, Organizing Business and Technology Teams for Fast Flow. That also fits pretty well into our idea of what the organization should achieve. So, sounds promising. Now, let's get in what team topologies tells us about the patterns that we can apply in our design process. So, the first thing is that the smallest unit of delivery in the context of team topologies is a team. Yeah? This is like the foundational building blocks for the whole pattern language. And it's quite interesting. Why? Because why a team? Why not a single person? Yeah? So there are a couple of pretty good reasons for this. Innovation generally is driven a lot by human interaction. Yeah? We benefit from diversity of opinions, also from the possibilities to discuss different ways how to tackle a problem. And besides this, there's also this kind of psychological aspect. typically we as human beings tend to be more content and happier if we have other people to talk to. We'd like to share our professional successes and our problems with other people. Well, not in all cases, but I think generally this is kind of true. So, but if we consider the team as the smallest part of our basic delivery, it is also clear that it only works well if we have strong communication inside of the team. So, strong communication means strong communication is basically limited. Yeah? So you can't have very strong and trustful communication with a huge group of people. And there is a bit of research around this, and that says like the optimal size of a team where you still can maintain this kind of strong communication that is the basis for a trustful relationship is like 7 ± 2. This is also something that's pretty well known. It's like the 2 pizza teams from Amazon. I mean, there's a pretty good fit. Yeah, but I think there is pretty good evidence that this is like the optimal size. So another thing that we have to consider is that we need to build up this kind of trust, because we know that trust is one of the fundamental traits of high-performing teams. Yeah? Trust, you can also say psychological safety. I think this is strongly related. And this also means that we need to have time to build up this kind of bonding inside of the team. This also means that our teams must be stable in a way. They must last for a considerable amount of time. It doesn't mean that they need to be completely static, but still, I think it's important that we don't have too high fluctuation. Otherwise, we just can't build up this kind of trust. That's really important for high performance. So now, this is what team topologies basically calls the team-first approach. Yeah? So we have strong communication, we have stability in the team, we have a diversity of opinions. All this together gives this kind of strong trust, yeah, which at the end will lead to motivation and innovation. Now, as we've established the basic fundamentals, the core pattern, yeah, we need to come actually to a way how we can distribute the work to this kind of teams. Yeah? And team topologies provides us different team patterns with different tasks. So I start with the base one. It's called the stream-aligned teams. This is the kind of team that actually provides customer value at the end. Yeah? Stream-aligned is also kind of a bit of a name that needs to be explained. The reason is, you could also say product team, but it's like not necessarily a product. It could also be a service, or it could be a set of features, whatever. But there is one defining trait, and that is that the teams are basically able to individually deliver customer value. This is very important. Yeah? They should be autonomous in a way that that dependency on other teams are reduced. They should be able to decide on their own. This also implies that they work in a kind of DevOps mode. Yeah? So they are able to cover the whole chain of delivery, of the software delivery process, starting with the creation of ideas, implementation, quality assurance, taking care about their tool chain, maybe most likely operations, maintenance, support. So you already see, I mean, this is like a lot of stuff that a team needs to do. And remember, I mean, we're just like 7 plus minus 2 people. So generally, I think this is something that just doesn't work. And we also have already heard that this kind of constant feeling of being overwhelmed about what we need to do as a team is creating a lot of stress, and this is not what we would consider a good place to work. Yeah? So we need to get an idea about first, what is it, how high is the load on the team? Yeah? Because, I mean, it's clear that the capacity is limited. We have like, I don't know, 7 people, they work like 8 hours per day, so 7 times 8 is 56, yeah? So even in that respect, the capacity is limited. But the work that we do as software engineers is not like working in a factory, stamping out parts. Yeah? It is complex mental work, so just counting hours is probably not the appropriate way how to measure the load of our teams. We need to have some kind of other ways how to manage the team load. And this is where team topologies basically introduced the concept of cognitive load. Cognitive load is a concept that is coming from learning theory. It was introduced in the late 80s by a psychologist named John Sweller. And again, the definition is kind of abstract. It says the total amount of mental effort being used in the working memory. So it's like something that helps us to kind of better understand the learning process. Now, one could say, okay, this is related to learning. Now we are talking about software development. How does this fit together? It's like two different things. But effectively, they are not two different things. And here, I have the quote from Dave Farley, and I think this is very appropriate. He says, like, software engineering is a discipline of learning and discovery. We build our learnings and solutions incrementally. This cycles back to how we handle complexity. Yeah? We need to try out stuff, learn, collect feedback, and learn from it. So that's like the process. So I think if you look at the software development process as a whole in the light of this quote, then it is really very appropriate that we apply concepts of learning that are born in the context of learning theory to the way how we develop our software. So John Sweller basically separated this cognitive load into different categories. Yeah? And I need to read it because it's also kind of complex. The first type of cognitive load is called intrinsic cognitive load. And it says this part relates to aspects fundamental to the problem space. Sounds abstract, but if we apply this to our work as software engineers, then this would relate to stuff like the knowledge of the programming language, the syntax, the semantics, these kind of things. Yeah? So this is what we call the intrinsic cognitive load. The second type of cognitive load is called the extraneous cognitive load. And again, the definition here is that it relates to the environment in which the task is being done. Translate this to our work as software engineers, it would be how do we configure our systems, how do we deploy our software. And then there is a third part that's called the germane cognitive load. And this is related to the aspects of the task that need special attention. For us, translated again into our sphere of work, this would be everything that is related to the business-specific problems that we need to solve. So add all up, and then you come to like a total cognitive load per each team member. And now add up all of the cognitive loads of the team members, and you come to a concept of a team cognitive load. This is not a scientific process. You can't just measure this with some kind of meter. But at least you can. It gives you some idea how you can get a grip on this kind of things that the team needs to do in this kind of exhausting mental work. So from a business perspective, these types of cognitive load do not have the same value. So we have intrinsic load and extraneous load, but actually the capacity that we spend here is not providing any customer value. It's just like how do we know our languages? Do we know our tool chain? Customers don't care about these kind of things. They, of course, want to have their problem solved. So the intention must be that we first make sure that the stream-aligned teams are not overwhelmed. And what we also need to do is we need to make sure that we shift the proportion of our mental capacity into the direction of the germane cognitive load, the part where the business value is. So that is the goal. Minimizing the intrinsic and the extraneous cognitive load and maximizing the germane cognitive load. Now, how can we do this? Team topologies provide some help here because it defines a set of a supporting system, you may say. And this supporting system is basically given by teams that help the stream-aligned teams to reduce the cognitive load, make their life easier. And the first type of team, and this is the team pattern 2, was already also mentioned by Eduardo, it's called an enabling team. Typically, this is a group of specialists that help the stream-aligned teams to get better in what they do. These specialists have the capacity to always stay on top of their game. They can follow what's going on in the technology market, something that takes a lot of capacity. You just can't put this on a stream-aligned team and hope that they also will be able to handle complex business requirements. That's not how it works well. So the enabling team basically can help the stream-aligned team to solve impediments that are there, help them to get better in what they do. as we now have two teams, and as our topology also is related to how these parts of the system are interacting, we now also need to think about what is the way how these teams are collaborating. There must be like a well-defined way, and the interaction pattern that team topology provides here is called facilitation. Facilitation means one team helps the other to remove impediments, more or less, whatever that may be. We at RBI have established an enabling team that is built around these kind of ideas, and it's the team that we call the engineering coaches. So engineering coaches are senior engineers that have a lot of skills, in our case mainly in the areas of continuous delivery and testing and test automation. They know the tool chains, they have a lot of experience. So they go work with the teams for a well-defined amount of time. So typically this facilitating interaction is time-boxed, and help the teams to get better in what they do. But the important point is that they don't do the work for the stream-aligned teams. They just help them in getting better. It's a coaching activity. This means that the people who work in these kind of enabling teams typically not only need deep technical expertise, but they also need to have good coaching abilities, so a mature set of soft skills. Good, so let's come to the next team pattern that's also pretty important and something that we know quite well, but in the context of team topologies always is like a bit of a different twist, and that's a platform team. Platforms are nothing new. We've had them for a while, for many years, but the difference here is that typically and historically, that's also my experience, platforms were purely created to save money. That was the only reason for existence for a platform. You also use centralized stuff so you can make it easier manageable and you save costs. Team topologies is not going in that direction. The approach why we would introduce platforms is completely different. We would only do this if we can make sure that first it reduces the cognitive load of the teams, plus it makes the life of teams easier. It supports them to achieve a better flow of changes to the customer. That's the only reason. It's not like we do this for costs, to save costs, but we do this to make the life of the teams easier. This kind of attitude towards platforms has a lot of implications. So the first implication is that the platform team basically treats the stream-aligned team as customers. So you need to make sure that you support the stream-aligned teams exactly in what they need to reduce the cognitive load, to be more flexible, to be faster. So the platform team needs this kind of product attitude. Every platform that we establish must be considered as a product. Again, this has a lot of implications. It means that the team who provides the platform needs to have this kind of product development capabilities. But they also need to take care about non-functional requirements. They need to make sure the platform has good performance, that it is available whenever it is needed. And it is also super important that there is a strong feeling that the platform must not create dependency. Because that's also something that was pretty common in former times. You centralize it, and suddenly you have like one platform, and everybody's depending on this. Everything is slowed down. You don't have touch points with the platform team. You can't get your stuff done, and everything breaks down. Or another typical case is the platform gets neglected. It just decays over time, but still you can't remove it because of hard dependency. So this is something that we absolutely want to avoid. As I said, we only centralize according to this pattern if we can help the stream-aligned teams to get faster, to get better in what they do, and to reduce their cognitive load. There is a special pattern of interaction here, and that is X as a service. That's the name, and I think it pretty much says already how this works. So we have a clear boundary between the stream-aligned team and the platform team, a clear interface. Typically, also, this means that platform services can be consumed via an API, in the best case, but at least we must make sure that the services can be consumed in a self-service way. So no stream-aligned team should be depending on the platform team to consume the services, because then, again, what we would have would be a strong and hard dependency. That's something that we want to avoid as the plague. Good. There is a fourth pattern that is introduced by team topologies, and that this is the pattern of a complicated subsystem team. there are some topics that really require a lot of skills and a lot of experience. Think about like complex mathematical models or video codecs or something like this. That's not something that you just can do if you're a Java programmer. You need to have years of experience, a very specific problem. In that case, it makes a lot of sense to centralize it. And again, let the streamline teams interact with this according to the X as a service pattern. These kind of complicated subsystem teams are entirely optional. There are many companies where this is just not needed. You don't have these kind of special requirements that that would mean that you need to set up these kind of teams. So very simplified, that's what the Mickey Mouse organization would look like. Yeah, you have a couple of streamlined teams. They consume services from a platform team via the pattern of X as a service, and you have an enabling team that is working with streamlined team 3. So that's very simple. I mean, like, sure, you know, real life is a bit more complicated, but just should give you an idea. So let's just recap. The pattern language is actually pretty simple. So we have 4 team types, and we have 3 mode interactions. I just showed you 2. So, but I will immediately talk about the third one, because the third one is special, and it is called collaboration. And again, the name says it all. Yeah, it is characterized by strong collaboration between 2 teams. This sounds a bit like a contradiction, because I've been talking now for minutes about how we should avoid dependencies and these kind of things, and now we introduce a collaboration pattern that means 2 teams sitting together very closely, maybe even mobbing, and like strong interaction. But this is not a contradiction, because what's important to understand, and this is also one of the fundamentals of this whole pattern language, we are not talking about a static organization. Yeah? Things are moving. The way how teams are how the team setup is done is moving. The way how teams are interacting is moving. It's like dynamic, and that's completely natural. We need to accommodate the changes of our architecture. Think about Conway's law. Our architectures are evolving. We need to understand that the more we learn, the more our architecture will change. We need to also reflect this in the organization. So it means that also our organization must be as dynamic as the changes of our software architecture. Otherwise, we will fall into the trap, and Conway's law will hit us, and we won't be able to flexibly react. So just as an example how this collaboration pattern would evolve over time. So first you would have a streamlined team that may be working together with a platform team that's newly established. They just need to figure out what exactly the services are that the streamlined teams would need. So they work closely together in this kind of collaboration mode for a given time. So again, this is time-boxed. Here, they can sit together, they can exactly learn the ways of working of the streamlined team and how the platform team would be able to reduce the load. So after a while, you need to move over to a different way of collaboration, something that takes a bit less bandwidth, but because we must not forget, this kind of interaction with other teams also is a burden on the complete team, on the complete cognitive load of the team. So if not absolutely needed, we should try to move to a lower bandwidth way of communication. Good. So this is the set of patterns that is provided by team topologies. If you want, this is the pattern language. This is a very superficial description. There are a lot of nuances to it. Some of them were mentioned by Eduardo, but generally, I think one could say that the pattern language actually is rather simple. It's straightforward, but still, I think it's a very useful model, a very useful mental model that can help us to get some kind of ideas how we can tackle this complex problem of organizational design and organizational evolution. So I think this whole thing is very useful. It's another tool in our toolbox that could help us with this problem to design an organization that is both successful from a business perspective, but on the other hand also allows us to create a workplace that's good for us as human beings and rewarding. So it seems I'm not alone. So in being inspired by this. Also, our ex-chancellor is of the same opinion. And with that, I'm done and say thank you.